To find the point of intersection of two lines, we're just going to use the fact that, if you like, in x and y terms, the x and y coordinates would be exactly the same at that point. So in this case, what we can see is that at that point of intersection, R1 would equal R2. So that's going to give us a set of simultaneous equations that we can solve. So our first equation will be 3 plus 6 mu equals 5 minus 2 lambda. Our second one will be minus 5 minus 4 mu equals 3 plus 6 lambda, and our third one will be 3 plus 3 mu equals 6. So in this case 3 is the obvious choice to start with because solving that will give us mu. So this will lead to 3 mu equals 3, and therefore mu equals 1. So first of all, we need to actually prove that they really do intersect. So we're going to substitute mu into both equation 1 and equation 2. If we get the same lambda from both of them, then that means that they do definitely intersect. So let's look at number 1 first of all. So that'll be 3 plus 6 equals 5 minus 2 lambda. So that's going to give us 2 lambda equals 5 minus 9, so that's minus 4. So lambda would be equal to minus 2 from equation 1. Now let's check out equation 2. So we'd have minus 5 minus 4 equals 3 plus 6 lambda. So we're going to have 6 lambda equals minus 9 minus 3, so that's minus 12. So that gives us lambda equals minus 2. So because they're both the same lambdas for the same mu, then that means yes, they do intersect. So the final part of this is we need to actually write down the vector that is the point of intersection of these two lines. And you can either pick the R1 and substitute in the mu, or you can pick the R2 and substitute in the lambda. I'll do both just to show you that it doesn't make any difference. You get the same thing either way. So R1 equals 3 minus 5, 3, plus our mu, which is 1 times 6 minus 4, 3. So adding those together, 3 and 6 gives us 9, minus 5 minus 4 is minus 9, 3 and 3 is 6. So now let's do the R2 one. So that gives us 5, 3, 6, minus 2, because we're replacing the lambda, minus 2, 6, 0. So 5 minus 2 times minus 2 is plus 4, so that gives us 9. 3 minus 2 times 6, which is 12, so 3 minus 12, which gives us minus 9. And 6 minus nothing is 6, so you can see that it doesn't matter which way we do it, and this would be our point of intersection. So as I mentioned, not all lines do intersect. So we're going to go through the process and find out if these do or don't. So remember, we're just doing equating to find those equations to start with. So for the first one, we're going to have 3 plus 2 mu equals 1 minus lambda. The second one will be 1 minus mu equals 4 plus 3 lambda, and the third one will be 2 plus mu equals 4 plus 2 lambda. So this one isn't quite so easy to start off. We're going to have to do simultaneous equations right from the start But if you look carefully, you can see that 2 and 3 would make it easy to eliminate mu. So we're going to do 2 plus 3 to get rid of the mu. So on the left hand side we're going to have 3. On the other side we're going to have 8 plus 5 lambda. So that means 5 lambda equals minus 5. So lambda equals minus 1. So now what we're going to do is check that out in equation 1 first of all. So that will be 3 plus 2 mu equals 1 minus 1. So that's actually 2. So we've got 2 mu equals minus 1. So that would be mu equals minus a half. But for us to prove that they intersect, we need to be able to substitute in this value of lambda and this value of mu into one of the other equations, and if it all works out then that's fine. Okay, so let's pick equation 2. So we've got 1 minus a half, so that's plus a half. That would be the left hand side. And then on the right hand side we've got 4 plus minus 3. So on the left hand side we can see we've got 1.5. On the right hand side we've got 1, and they don't equal each other, and therefore these don't intersect.